Applying rigid motions to triangles creates congruent triangles. Any of the three rigid motions, which are translation, rotation, and reflection, will create an exact copy of the triangle, just in a different location. Here we see triangle ABC and triangle DEF, and these two triangles are congruent because triangle DEF is a rotation of triangle ABC, rotating 90 degrees about the origin. We know that triangle ABC and triangle DEF are congruent. Triangle DEF and triangle GHI are congruent as well because triangle GHI is a reflection of triangle DEF, and reflections are one of our rigid motions, and rigid motions create congruent triangles. We know that triangle DEF is congruent to triangle GHI. Now let's take a look at triangle ABC and triangle GHI. These two triangles are also congruent because each of these rigid motions created a congruent triangle. Triangle ABC is congruent to triangle GHI. Applying a rigid motion or applying a couple of rigid motions to a triangle creates copies of congruent triangles. Let's check for understanding. Which graph can use rigid motions to show triangle ABC and triangle GHI are congruent? How do you know? There are two different graphs with the two triangles, triangle ABC and triangle GHI. Blank can use rigid motions to show triangle ABC and triangle GHI are congruent because looking at the size of the triangles, triangle ABC and triangle GHI appear to be congruent on graph A, but on graph B, triangle ABC and triangle GHI do not appear congruent at all, which means A. Graph A can use rigid motions to show that triangle ABC and triangle GHI are congruent, because their shapes overlap perfectly after one rigid motion. This is the rigid motion of a translation, sliding the shape over and then down.